Hi everyone, we're going to use congruent triangles to prove corresponding parts congruent. So basically we have an example here. Can the triangles be proven congruent with the information given? And for A, that's not enough information because no sides are known to be congruent. All we have is some side. So we want either, for this video, we want angle, side angle, or angle, angle, side. So for the second one, this one's angle, angle, side, because this side's congruent to both. So you have angle, angle, side for that triangle, and then we also have angle, angle, side for that triangle. And for this one, we have the vertical angles are congruent. So that's this one and this one. That gives me angle, side, angle, and angle, side, angle. So that's the angle side congruence postulate as well. Here's an example of that flow chart we talked about in the previous video. So in the diagram we have angle 1 is congruent to angle 4, and this bisects ACE, this whole triangle. It bisects it, and we have to show a flow proof to show that the triangle CBF, this would be C, where's B? Oh, CBF, so let's do that one. CBF is congruent to CDF. So this is CDF. So the solution is you write your given, which is already given up here, and this is your proof. So basically the flow chart would be you write down your given here and here, and you know that angle 1 and 2 are supplementary angles, and 3 or 4 supplementary angles. And that's the definition of supplementary angles. So basically, you can say that angle 2 is congruent to angle 3. And we know that CF is congruent to itself, this line right here. That's a reflexive property. And then so you add all three of these. We also have the angle A. Let's erase this. Angle ACF is congruent to ECF. So that means these are congruent. Therefore, by the angle side angle congruence theorem, the triangles are congruent. All right, so that's an example of a flow proof chart, and we'll do more of that in class. And finally, here's another example of a flow chart. Given the example 2 we just did, so we want to prove the triangles are congruent. So we write that CF bisects each piece, so we had each piece here. This is your CF. And we write down our givens and our reflexive property in the middle. And then that shows that the angles are congruent by the angle side angle congruence postulate. So just a different way of writing a proof. We're going to do this in class. We're going to do the 2-column proof and then the flow proof to see how it matches up. All right, here it says you are working 2 spotlights for a play. So here's your 2 spotlights. The 2 actors are standing apart from each other. The spotlights are located here. Can one of the actors move without requiring the spotlight to move and without changing the distance between the other actor? Alright, so basically, let's see, you can say the measure of the two angles and the non-included side are known. So we have, this is the side. So that's 20 feet. By the angle side congruence theorem, all triangles with these measures are congruent. So the triangle formed is unique, and therefore the actors cannot move without requiring the spotlight to move and without changing the distance between the other actor. And basically this goes along with our stable structures. So when we're talking about stable structures, a triangle is stable if the sides are congruent. So this would be a stable shape, and so it's fixed. So when you're trying to move the pieces, it's going to require the angles to change. Okay, so this is it's just like your stable figures. And that's it. Thank you. Have a nice day. Bye bye.